Okay, we're going to start off section 6-7 here with a review of solving for multiple angle problems. Multiple angle is when the x has a coefficient in front here. And really, the procedure that we want to go through here is if we're asked to solve for 0 equals cosine of 2x, all right? We can think of this a number of ways. I have a graph over here. A good way to think of this is visually. And remember from graphing, when we had y equals the cosine of 2x, that 2 there affect the period. And that the period would then be 2 pi over 2, okay, or just pi. And that's going to have an effect on our solutions here. So we need to keep that in mind as we go. But one thing that we can do is we can substitute u for 2x, okay? And then we're going to solve for u. Once we get u by itself, we will put 2x back in for u, and then solve for x. Okay, so what we can do here is say that 0 equals cosine of u, right? And u cosine equals 0 when u equals pi over 2 plus pi n. Okay? Every pi units after pi over 2. Now, once we solve for u, we can substitute back in the 2x, all right? And we can solve for that by multiplying both sides by 1/2, okay? And what we end up with is x equals pi over 4 plus pi over 2n. Now, that is a general solution. This would be like a general solution for all the times that cosine 2x hits 0. And if you think about it, if we consider this 0 and this pi here, you can see that it hits it in those two places. This would be pi over 4. And if we add pi over 2 to that, this would be 3 pi over 4. Okay? And so here's the general solution. If they asked us for our solutions, you know, from 0 to 2 pi, those solutions would then be x equals pi over 4. That's where we get this 0 to p. The period in this case is pi, and 3 pi over 4. Okay? So that's just a review. Being able to deal with multiple angles will help us tremendously in this task. Okay, now we're going to start doing more with trig equations. We're going to look at trig equations in a quadratic form, which is what we have here. Alright, notice I have a sine squared and a sine to the first power, and also a constant here in the 1. So I've got to treat this like a quadratic. Alright, and we had 3 ways of solving quadratics: factoring, completing the square, and quadratic formula. All of those, I always have my students start by setting the quadratic equal to 0. So I'm going to collect all my terms on one side. And then this one here, without getting real tricky, we can factor. And we're going to factor it by grouping. So if you remember how to do that, take 2 times -1, factors of -2 that add up to be 1, and I split the sign apart, and I can say this is 2 sine squared x minus sine x plus 2 sine x, okay, minus 1. This is factoring by grouping again. Group the first 2 terms and the last 2 terms. I factor out a sign. And I don't need to take anything out of this second term because it matches my first. And since we have a 2 sine x minus 1 with both of these here, I can factor those out. And so I end up with 2 sine x minus 1. All these equal 0, I'm sorry. Times sine x plus 1. Now once we have our factors set equal to 0, I can set each independent factor equal to 0. And so from here I would get 2 sine x minus 1 equals 0 and sine x plus 1 equals 0. And then we continue to solve here. So we get, where does sine x equal 1/2 and where does sine x equal -1? Well, that happens when x equals pi over 6 plus 2 pi n, 2 pi k, or when x equals 5 pi over 6 plus 2 pi k. Those are the two general solutions for that factor. Sine equals -1 when x equals 3 pi over 2 plus 2 pi k. Okay, so here would be all of our general solutions. Alright, and then if I want my solutions from 0 to 2 pi, I would get x equals pi over 6, 5 pi over 6, and 3 pi over 2. And those would be my solutions on the interval from 0 to 2 pi. And that's it.